Did you guys get candy yesterday?
No.
No? Okay, I couldn't remember if it was you or the other class. So the other class got candy because they had the highest quiz average. I give out candy to the entire class, for the class that has the highest quiz or test average. So for the quiz, it was 1% difference. 1%
I
difference.
think it was us.
I'm pretty sure that was us.
Yeah.
See, really? Lied. We did get candy.
Oh, you did get, okay, good. Because I was thinking, I definitely should not give you candy today because you're so worked up. It would be a bad thing. All right, so.
Oh, you greedy bastards.
Language.
Can I run my 11.5 notebook?
Quicker. All right, so nets and dot drawings. We're starting chapter 1. We're going to start actually talking about geometry. You guys don't need to know about substitution yet. All right, so we all knew for our opener, we all knew what a net was. A net is just a way of visualizing. A net is a way, let's stop talking, guys. A net is a way of visualizing some kind of three-dimensional shape. And we'll talk about a couple of other ways to visualize three-dimensional shapes in just a second. So let's draw a net like we did for our opener. Just add a little something to it. Just talk about how we visualize. So we're going to draw the same net that we had up on the board. Doesn't have to be perfect. We just want to think about how things work. All right. So there's my net. Now, before I go on, could I draw this net differently? Is this the only way to draw a net for a cube? No. Could I draw it? Could I move this piece over here? Would that still work? If I folded it up, would I get all the sides covered up? Okay. How about if I move this piece? Could I move it over here? No, because what would happen with that side? It would overlap, right? Or we would make a 5-sided shape and this wouldn't close the end and there would be nothing on the other side. Could I put this here? Yeah. So we'd fold these two up. Those would be the sides, and then these would fold up to be the two sides, and this would come over and be the top. So we can draw it that way. Draw this a lot of different ways. So there is usually more than one way to draw a net. I'm just going to go back to this way, and we're going to put some numbers on this. Or not numbers, letters. E, D. So that's a nice thing in math. We can use letters or numbers. So it's even cooler than doing language, because you can use letters and numbers. Speaking of language, did you hear about the math contest in the LA department? Someone said, the person said 7 plus 7 was 12 and got 3rd place. Seven plus 7, so if they said 12, they got 3rd place. The person that said 13 got 2nd place, and the person that said 14 won. All right. It's a good thing it's Friday. All right. So we want to visualize this. Which side? Which side is opposite the letter D? If we fold this up. F. D, we can think of D as the bottom and F as the top. How about which side is opposite A? B, that's pretty easy. And which side would be opposite E?
C.
C. So if we folded this up, I'm going to draw a little picture here. So this could be maybe a standard letter cube, right? 6-sided cube with letters on the side. So if I say this side is D, we said F is the other side, so F would be the one that we can't see back there. If this was B, then the opposite side of that would be this side we can't see down here, which would be A. And we could say this would be C, then fold that up to be C. And this side would be E over here, when we folded that thing up. So this just, a net is just a way of helping us visualize what a three-dimensional shape is. And we'll talk, the next thing we want to do is talk about how we would use a net, maybe to get some information about a shape. So we're good here. We're pretty good at folding up this thing. Yes, good. All right. Well, let's say we have a shape, a box, and we want to draw a net with dimensions. So here's my box, and we'll label some sides. I know this isn't to scale. This is 7 inches. Let me make this a little smaller here. This is 2 inches, and it's 12 inches high. And we want to make a net for this shape. So let's start off with this side. So I'm going to say, I'll just put some red here. We'll start off with that side. So what would the dimensions of that side be? What would this length be? 7 inches. And how tall would it be? 12, right? And now let's add this side. So this is the red side here. Let's add the blue side on there. So how wide is this going to be now? 2 inches. I'm going to put that inside. And it's still 12 inches tall. All of these are 12 inches tall. And then we go around to the back. How big is the back side going to be? And this is our blue side. How big is this back side going to be that we can't see? It's going to be 12 by 7 again. Oops, let me get that to black. So that's still 12 inches tall, and this is going to be 7 inches. And then we have this side over here that we can't see, that's opposite the blue side. So how big is it going to be? 2 by 12. So it goes there, and that's going to be another 2 inches and still 12 inches tall. And then we need to put the lids on, the top and the bottom. So what are going to be the dimensions of the lid? What is it? 7 by 2. So I'm going to attach it to a 7-inch side, and it's going to go up like that, and that would be 2 inches, and I can put another one down here. So that would be my net with the dimensions label, and we know that the height on all of them is 12 inches. What would this help us do? The surface area, right? All we're having, we'd find the area of all these rectangles, and that would tell us the area, the total area on the outside of that box. So we could find the surface area. And when we talk about three-dimensional shapes a little bit more, that's what we will do. We'll talk about formulas for surface area, and we'll show how the formulas come from the nets of the shapes. It's kind of nice to be able to talk about how that formula comes from the net, because the net is really easy to visualize. All right, questions there? Okay. Next piece is my favorite part. We call these isometric dot drawings. And I need to do one thing really quick. I need to get my dot paper, so I'm going to freeze this. Just in case I have confidential information open under here. I'm going to go to my... Yes. My calculus students made this T-shirt a couple of years ago, and they said they had a bunch of Mr. Beamer quotes, so they put my face in one of my quotes on there.
What's the quote?
It's pretty straightforward. It's a really complicated problem, and they said I say it's pretty straightforward a lot.
You have said that a few times already.
I have said that a few times already. Is that
Well, now that you pointed it out, now that you remember it.
Yeah. I don't even think about it. It's just one of those, I was like, really? I say that? And now all the students go, yeah. All right. So now I'm ready with my dot paper. So the next little bits, we're just going to draw some pictures just as an example on our dot paper. So I'm going to grab a picture here and I'll put it onto the sheet there. So isometric dot drawings. Isometric just means that all the dots are the same distance apart. So these distances, this is the same, all these distances are the same. And what it lets us do, isometric dot drawings are just another way to visualize 3D shapes. And these 3D shapes that we're going to talk about here are all going to be made up of little cubes. And what we usually say with isometric dot drawings is that the cubes, there aren't any cubes that are missing that we can't see. So there aren't any holes in our drawing that we can't see. And when we do this drawing, it'll make sense. So our shapes are made of cubes, and there are no holes in our shape. No holes that we can't see. So to make a cube, all I do is connect some of these dots. I'm going to do this in red. And there I have a nice little cube on my paper. And if I want to draw the cube rather than looking at the top, I want to draw looking at the bottom. I'm going to do the same thing. I'm going to start with these here, and I'm going to go, no, that gets me to the top. How do I want to start here and go up. And that's looking at the bottom of the cube. So I made my little pieces point up here, and then I went up from them to get the bottom of the cube. So I can get different views of my cubes. And we can build up shapes with these. So let me grab another piece of the dot paper, and I'll put it on there, and we'll draw a more complicated shape. So if we wanted to build up something, some shape, so I'm going to put a cube here. And I can make it go a few cubes back this way. And then let's make it go up. So there's kind of an L shape. And we can make our shape bigger. So let's do this. And these are just examples, we're just practicing. And I'm going to make this go up here. And let's go out this direction. There. So now we have a little shape with the cube stacked up. And when I said there are no holes that we can't see, so back here behind this cube, we're saying that this space underneath isn't empty. So there'd be a cube back behind, so I forgot that, behind these two. Going to grab one more piece here, and I just want to make a couple more shapes that are. And if you guys aren't getting all of these, that's fine. There's just a few of the homework problems where they ask you to do isometric dot drawings. So I just want to just show you how you can make. I'm just making these up because I like doing these. So let's build this back a little ways here. It's almost like building with Legos. So now we have a cube back there. It's almost like building with Legos, except you're just drawing it on paper rather than actually building it. And we can build this up. So now we have this shape with these pieces out. If I wanted to make this square out in the front, take that away. I'm just going to do this. And now I've taken that square away. And we can build this further back. And there's another piece there. And I need to put that there and connect that there. So now I have a more complicated shape. And I could build it up. I could keep building it up as much as I wanted. Did I do something impossible here? I think I did. I have an impossible square there. So there we go. That's better. I just like doing these dot drawings, so I'm just messing around. So you can make all kinds of different shapes with your isometric dot drawing. So on your homework, it asks you to make some drawings, make some dot drawings, copy some dot drawings from the textbook, and you just follow that process. You're just connecting these squares. Make a little stack here. I just think these are fun. So those are a couple of examples of drawing with the isometric dot paper. Just another way of visualizing three-dimensional shapes, simple three-dimensional shapes. And this would let us think about the volume and the area of these little shapes, because we can think about the volume and the area of those little cubes. Questions on dot drawings? We're just using them to visualize these shapes a little bit and get into the habit of getting some practice thinking in three dimensions. All right, the last thing we need to talk about today. One other way of visualizing 3D shapes are called orthographic drawings or views. So the orthographic drawings don't go on the dot paper. The only ones that go on the dot paper are the isometric dot drawings. So we call that isometric dot drawings. Orthographic drawings just go on your piece of paper. Orthographic drawings, just another way of visualizing 3D shapes. It's just, they are 3, and sometimes you can do more. 3 or more flat views of a shape. And what we do in this, what this book likes to do is a front to top and a right. A front view, top view, and a right view. We could do the back, the left, and the bottom if we wanted. For what we're doing here is just the front, the back, and the right. So let me draw a shape. So this is just kind of a freehand of one of the shapes we did on our dot paper. So we're going to stack two cubes this way. Whoops, I don't want to put that there yet. And we're going to go over this way by a couple of cubes. So we had a shape like that on our dot paper. We want to talk about our orthographic views using this. So from the front, so we're going to draw what this would look like flat from the front. So we're not drawing 3 dimensions, we're just drawing it flat. So from the front, this is just going to have these squares. So that would be our drawing from the front. That's our orthographic view from the front. What is this going to look like from the top? If we look straight down on the top, what would we see?
3 boxes in a row.
Just 3 boxes in a row, right? And from the right-hand side?
2 boxes.
Yeah, just 2 boxes. We're looking from this side like I'm looking at it flat this way. We just see 2 boxes stacked on top of each other. So those are our 3 orthographic views. And we could put these together to get an idea that our shape looks something like this. Now what would happen, how would our orthographic views change if I added a box out here in the front? So I stuck an extra box out here. Would that change the front view? What's that? The front would be the same, the top and the right would look different. So what would happen to the top view here? On the side on the left, right? So I'd get this extra box here, looking down on it from the top. And then on the right view, if I'm looking at it straight this way, where's my extra box going to be? On the left, the top, bottom. So if I added that extra box, this is what I'd see from the right. And if I put those 3 together, I'd have an idea that my shape looks like this. So the orthographic views are just asking you to look at, make three drawings of this shape flat. Just another way of visualizing what a 3-dimensional shape looks like. Questions? Okay. Homework. So we're going from page 870 to page 7. So there's the homework. Common Core or Math Box 1 and Algebra Review 3 due next week on block day. As soon as everybody has this written down, I have the book page ready to go. The first several problems are super easy. None of these problems are difficult, but the first ones are really easy.